This is Chapter 17, Solubility. It's the KSP chapter, and it's the very last of our equilibrium chapters. The information that you're going to find here in the first couple questions come from section 17.1. So if you have any questions on this, look at 17.1, and it's an amazing chapter. Okay, so let's just do this first. The KSP of calcium phosphate is 1 times 10 to the negative 26th. The question says, find the molar solubility of calcium phosphate. Well, this is the KSP thing. This is a solubility. So the first thing we're going to do is write the reaction to show how calcium phosphate does disassemble if it indeed happens. So you have calcium phosphate, that is a solid. You put it into water. It's going to be split up by the water molecule. And the water molecule will break it into 3 calcium ions and 2 phosphates. Now, this hardly ever happens because +2 and -3 are huge magnets, and so those guys actually slam together. So it's very rare that calcium phosphate disassembles. Matter of fact, you'll start with some of this, 0 calciums, 0 phosphates, and X amount will disassemble, and you're going to get 3X here and 2X here. So at the end of the game, you're going to have 3X of calcium ions in solution and 2X of phosphate ions. So you write the KSP expression for that. KSP is going to equal the calcium ion concentration cubed times the phosphate ion concentration squared. And remember, those come from that. And that 3 came from that. Okay, so you have your phosphates squared, you've got your calcium ion cubed. Now, you're given the KSP. So KSP is 1 times 10 to the negative 26. That's going to equal 3x quantity cubed times 2x squared. Now, it doesn't matter to me how you do the math. You can just plug and go, solve for x. 3x cubed would be 27x cubed, and then this would be 4x squared. So you could do it that way if you want. Let's see, one exponent, negative 27 divided by, or negative 26 divided by 27 divided by 4. Take the 5th root of that number, and I'm going to get x equals 2.5 times 10 to the negative 2.47 times 10 to the negative 6. This is moles per liter. X is in moles per liter. Okay, make sure you can do that with your calculator to get the answer. Now, X is, if you scroll back up, X is a solubility. Okay, X is how many guys actually disassemble and come over to the other side. Okay, now let's go down to number 2. Number 2, you're given the KSP of zinc hydroxide is 2.1 times 10 to the negative 16th. Find the solubility in grams per liter. What we did before was in moles per liter, and so we're going to do the same thing, but now we're going to switch moles to grams. So let's write our equation. It's going to split into the zinc ion and 2 hydroxide ions. This is a solid, so you start with stuff, nothing here, nothing here. X amount will actually split up and give you X and 2X. So our KSP expression will say the zinc concentration times the hydroxide squared. And KSP is 2.1 times 10 to the negative 16th. So that's going to equal X times 2X quantity squared. So 2.1 times 10 to the negative 16th divided by 4, and then I'm going to take the cube root of it. So my X is 3.74 times 10 to the negative 6th. That's my X. It's 3.74 times 10 to the negative 6. That's my molar solubility. That X is that X. Now, the question is, what is this in grams per liter? So that's how many moles per liter of zinc hydroxide will disassemble. So all I need to do is change that to grams per liter. And the molecular weight of zinc hydroxide is 82.39. So I'm going to take 3.74 times 10 to the negative 6 moles per liter and times it by 82.39 grams per mole. That cancels out my moles. And I will get 3.74 times 10 to the negative 6 times 82.39. I get 0.00308. In other words, 3.1 times 10 to the negative 4th grams per liter. Now, number 3, we're going backwards. We have lead sulfate. Okay, the solubility of this at 25 degrees is 4.25 times 10 to the negative 3rd grams per 100 milliliters. What is this KSP of lead sulfate? Well, do the exact same thing that you always do. Okay, what you want to do is split it up into the lead ion and the sulfate ion. You start with stuff here, nothing here, nothing here. X amount disassembles, you get X and X. And so this is what you have at equilibrium. And KSP is going to equal the lead concentration times the sulfate ion concentration. Okay, well, we need to know what X is. And we're given X, but it's given to you in a different unit. 4.25 times 10 to the negative 3rd grams per 100 milliliters. We need to change that to grams per, or 2 moles per liter. Grams per 100 milliliters. Well, I'm going to times that by 1 mole for every whatever the molecular weight is. So I'm going to add that up. Lead, 207 plus 32 plus 64. It's 303 grams per mole. That's going to cancel out the grams. Now I need to change milliliters to liters. So I'm going to times this by 1,000 milliliters per liter. And that will cancel out my milliliters. The dimensional analysis gods will be excited. Let's see. And I get 1.4 times 10 to the negative 4th as my solubility. That's X, which is going to plug in there and, everywhere else. So KSP will equal 1.4 times 10 to the negative 4th squared. So it's going to equal 2 times 10 to the negative 8th. Nice. Okay, moving on. What's the pH of a saturated solution of calcium hydroxide? Okay, here's the deal here. If we have calcium hydroxide, and if he does disassemble once in a blue moon, then he will produce the hydroxide. And the hydroxide will cause the pH to be above 7. So if we can find out how many OHs here we have, then we're going to hit our log button and calculate the pOH and subtract from 14 to get the pH. So first things first. Let's do our table, 0, 0, x, 2x. And we know that KSP is the calcium concentration times the hydroxide squared. And you're given KSP. So what we're going to do is we're going to find X. And when we find X, the hydroxide concentration is 2X. So let's plug in our number here. 6.5 times 10 to the negative 6th. That's going to equal X times 2X quantity squared. So that's 4X cubed. So 6.5 times 10 to the negative 6 divided by 4. Take the cube root and that is 0.012 moles per liter. That is not X, or not the hydroxide, that is X. Your hydroxide concentration is 2X. Why is it 2X? Because every time one calcium hydroxide disassembles, you're going to get two hydroxides. So your X is 0.00 or 0.0118 is what I got. Which means when one of these guys disassembles, I'm going to get twice as many OHs. So 2X is my hydroxide concentration. Which is 0.024. So if I say POH is the negative log of 0.024, then I'm going to get 1.9. And then if I subtract from 14, I'm going to say my pH is 12.1. POH was 1.9. It's a little bit high because OH is a strong base. Okay, next one. pH of a saturated solution of barium fluoride. So now the fun is beginning, because with barium fluoride, when he disassembles, you're going to get the barium ion and two fluoride ions. Well, barium is neutral, but when you get the two fluoride ions, these two fluoride ions are basic, and they're going to jump into water and make HF plus the hydroxide ion. And so you're going to have to use Kb and find out what the hydroxide ion concentration is. Okay, so let's do the first things first. Whoops, we got to do this slowly. Alrighty. So we have to find out what the solubility is. So this is stuff here, nothing, nothing, x minus 2x, or plus 2x. Alright. So at equilibrium, our KSP is going to equal the barium concentration times the fluoride ion concentration squared. And the KSP is 1 times 10 to the negative 6. That's going to equal x times 2x quantity squared. And so I'm going to go 1 exponent negative 6 divided by 4, take the cube root, and my x equals 0.0063 moles per liter. That's that. Now remember, your fluoride ion concentration is 2x. So when we go to the next spot, I'm going to say that the fluoride ion concentration is 2x, which equals 0.0126 moles per liter. Okay, now we can take this and do the equilibrium dance. The fluoride ion plus water will give you HF plus hydroxide. This is like an old friend now. 0.0126. Nothing, nothing, minus x, x, x. And then you have 0.0126 minus x, x, x. Ka is 6.8 times 10 to the negative 4th for HF. So Kb is going to be 1.47 times 10 to the negative 11th. So I'm going to set that up. 1.47 times 10 to the negative 11th is going to equal x squared over 0.0126 minus x. So I'm going to times that, take the square root, hit my log button, my POH is going to equal 6.4 or 6.37, and my pH is 7.6. Excellent. Okay, so now we get to the fun. All right, what's the solubility of calcium hydroxide in a solution? So what we're saying here is we have a beaker, okay? It already has the calcium ion in it. The nitrate's a spectator because he's always soluble. So it already has that in it, and now we're going to